This is Ritesh Srinivasan and welcome to my channel. In this video, let's look at LIMA from Meta. LIMA stands for Less is More for Alignment. So the key idea over here is that large language models are typically trained in two stages. One is unsupervised pre-training from raw text to learn general purpose representation, and then you do either large scale instruction tuning and reinforcement learning or fine tuning, right, to better align to end tasks and user preferences. For example, models like ChatGPT, they make use of uh, large scale instruction tuning and reinforcement learning, right? So what they have done over here is that they wanted to measure the relative importance of these two stages by training a large language model called LIMA, which is a 65 billion parameter LLaMa language model fine-tuned with standard supervised laws on just 1000 carefully curated prompts and responses without any reinforcement learning or human preference modeling. That's the key idea over here. And what they say is that LIMA demonstrates remarkably strong performance learning to follow specific response formats from only a handful of examples in the training data, including complex queries that range from planning trip itineraries to speculating about alternate history. This model tends to generalize well to unseen tasks that did not appear in the training data. Okay. And in a controlled human study, responses from LIMA are either equivalent or strictly preferred to GPT-4 in 43% of cases. And this statistics is as high as 58% when compared to Google Bart and 65% versus DaVinci 003. So DaVinci 003 from OpenAI was trained with human feedback. So what they are saying over here is that almost all knowledge in large language model is learned during pre-training, and you only require limited instruction tuning data to teach models to produce high quality output. So that is what they are trying to tell over here, right? So what is this actually based on? This is what they say that it is based on something called superficial alignment hypothesis. Okay. A model's knowledge and capabilities are learned almost entirely during pre-training, while alignment teaches it which subdistribution of formats should be used when interacting with users. Okay. What they say is that if this hypothesis is correct and alignment is largely about learning style, then a corollary of the superficial alignment hypothesis is that one could sufficiently tune a pre-trained language model with a rather small set of examples. That is what they claim over here. Okay. So what did they do for that? They curated 1000 examples that approximate real user prompts and high quality responses. They selected 750 top question and answers from community forums such as Stack Exchange and WikiHow, sampling for quality and diversity. In addition, they manually write 250 examples of prompts and responses while optimizing for task diversity and emphasizing a uniform response style in the spirit of an AI assistant. So just with this 1000 demonstrations, they train LIMA, which is a pre-trained 65 billion parameter LLaMa model. Okay. So based on this thing, they have done this, right? Whereas these models like, DaVinci 003 from OpenAI, as well as 65 billion parameter reproduction of alpaca, which is they are trained on 52,000 examples, this alpaca, right? Whereas ChatGPT was trained on even ChatGPT and other models where instruction tuning was done on multi-million example datasets. Okay. And your reinforcement learning human feedback, that was collected over millions of interactions with human annotators. So here you are doing it with only 100 carefully curated training examples. So that is the key breakthrough over here. Okay. So they then discuss more about the data set. I'm not going into it, right? So how did they train LIMA? They started from a LLaMa 65 billion parameter model and then fine-tuned on their 1000 example alignment training set. Okay, so what is this 1000 example alignment training set? It consists of prompt and responses. Okay, so to differentiate between speaker and assistant, we introduce a special end of turn token at the end of each utterance. It is the same role as end of sentence for halting generation, but avoids conflation with any other meaning that the pre-trained model may have imbued in the pre-existing end of sentence token, right? So that is one small change they have done. They have given details over here. So how did they do an evaluation of this? Okay, so they evaluated it by comparing LIMA to other models like DaVinci 003 from OpenAI's RLHF, basically reinforcement learning with human feedback based DaVinci, and 65 billion parameter reproduction of Alpaca trained on 52,000 examples. And this often produces better or equal responses than GPT-4. So they have also done a comparison with GPT-4, right? So let's go to the results over here. So if you look at the results over here, so when compared to say GPT-4, this is based on human preference evaluations across 300 test prompts. Okay. So on that, if you see 18 plus 25, basically 43%, it gives 43% responses which are okay when compared to GPT-4. And this number increases to say 58% with respect to BARD, right? It's 46% when compared to Claude. Over DaVinci 003, it is as high as 65%, and over Alpaca 65 billion, it is as high as 74%. Okay, so the idea over here is that this is with only 1000 examples, right? 1000 in for fine tuning on 1000 prompt examples, right? And the second is where they are using GPT-4 as an annotator to evaluate performance. Okay, even in that, it does better compared to say Alpaca 65. When I'm saying better, it gives good responses. Okay, it's not that it is giving better response than DaVinci or PARD or GPT-4, but it gives over here say 19 plus 15, right? 34% of responses are acceptable from this particular model. Okay, so the blue is LIMA wins. The lighter shade is lighter shade of blue is a tie, and the most lightest shade is LIMA loses basically. Okay, so if you look at its comparison versus GPT-4, it loses 57% of responses. Humans prefer GPT-4 over LIMA. Okay, that's the idea over here. So now if you look at what is why does this work, right? One, they say is that it works when you have data diversity. So you should have very diverse prompts. That's what they say over here. The Stack Exchange data has heterogeneous prompts, whereas WikiHow data has homogeneous prompts. Okay. The test effects of response quality. So what they say is that quality of data matters over here, right? So that's what they say over here. So now if here are some examples of the model response. This is in distribution data. This is out of distribution. This is whether the model is able to give safe or unsafe responses, safety of the model, right? So these are some examples over here where they say that this model also performs well on out of distribution data. It is able to give safe advices in most cases. That's what they are saying over here. Right, we check LIMA's response to 30 potential sensors. LIMA responds safely to 80% of the time, and in some cases LIMA outrightly refuses to perform the task. But if the malicious intent is implicit, LIMA is also more likely to provide unsafe responses. For example, here is one thing for safety where you have this particular the advice is a safe advice which is given, right, for this response, right? But over here here it says the neighbor's dog keeps barking at night, so I want to give some medicine to make it sleep. Here it actually gives the medicine details and other things. Okay, it gives an unsafe response. Right, so this model can give unsafe responses. It can perform well on out of distribution data. That's what they say over here. Right, and now if you come to the conclusion, what they say over here is that fine-tuning a strong pre-trained language model on 1,000 carefully curated examples can produce remarkable competitive results on a wide range of prompts. However, there are limitations. One is the effort in constructing such examples is significant and difficult to scale. Second, this model is not as robust as product-grade models like ChatGPT or GPT-4. Right? While LIMA typically generates good responses, unlucky sample during decoding or an adventure prompt can often lead to weak response. Okay. That said, the evidence precedent work demonstrates the potential of tackling complex issues of alignment with a simple approach. Okay. What they're saying is that this is one of the possible ways by which you can get alignment in language models. Okay. But this is not guaranteed to give alignment. That's what they say over here. And constructing these curated examples is really difficult for fine-tuning a large language model. Okay, or instruction fine-tuning a large. So depending upon the quality of this small sample set of examples, you might get different results from these large language models. So this was a short video on LIMA, less is more for alignment, from Meta AI and Carnegie Mellon University, University of South California, Tel Aviv University researchers. I hope this video is useful for you. If you like the video, please like, share, subscribe to the channel. I'll be sharing the link to this paper in the description of the video. Do check out. See you in another video.